The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Today is our field trial module webinar that we have hosted. We are going to be talking today about the new field trial module that is available in SMS Advanced. I am your host today. My name is Aaron Friedline. I'm a product manager for Ag Leader in the data management group. And we're going to talk today about some field trials that we put in here at our farm this spring, and we'll be going through some of the steps in order to get there. As an overview, the trial that we have developed is going to allow you to create trials for your farm or for your clients' farms that provide more in-depth results and more accuracy in determining the application rates, the timing of applications, machine settings, things that help improve the bottom line for your farm and for your customers' farms. So we're going to go through the process today. We're going to start with the new setup of a field trial. We're going to incorporate that into a prescription, go over the analyzing the results, and different grouping that can be done to get the most out of your prescriptions and your trials. The first step is to create a map of the field you'd like to conduct a trial in. We add that map and any other layers that you want to use to help define where you're going to put the field trial. This could be soil testing layers or management zones or what have you. If you've already created a trial, you'll see that in this list. For us, we have not created any, so we're going to create a new one. We're going to create a descriptive title for this and any other information that relates to the trial to make sure the goals of the trial are clear. We're going to select the units and the number of rates to test, along with if any of those are a control rate for what is traditionally done. In this case, we've set our 91 pounds an acre application as kind of our control rate. These are going to be used later on in the analysis process to identify where the break-even results are for the results of the trial. Next, we're going to set the parameters of the trial in terms of the number of replications and the number of blocks. We're also going to set the dimensions of the trial to match our application equipment that we're going to use. So in this case, we're going to apply some fertilizer with a 30-foot implement, and we're going to have about a 300-foot long treatment. And then when we come to the harvest information, we're going to buffer the ends of those treatments by 50 feet so that we can kind of eliminate any of the transition zone from one rate to the next to make sure that we're getting just as pure of data as we can. You can set this to whatever you'd like. You can set it to 0 if you don't want to have any kind of transitions accounted for. We're going to use 50 as a default, and this is going to leave us with 200 feet of length for each treatment. We can decide what's going to work best for our field. We can identify our trial to go end to end or side by side, depending on which way is best. We're also going to be able to randomize where those treatments are within the plot. This is done to help reduce the amount of bias that might be within that field, and we can keep clicking the randomize as often as we want until we feel like everything is where we want it. We can also manually adjust the rates if we feel like they just aren't fitting where we want them to. So, for example, I've clicked on the 183 pound an acre rate, and if I had changed to the 260 pound rate, those two treatments would just switch places. Using our placement of the field, we can place these trials in areas of the field that might match another field. So in other words, we're trying to eliminate the amount of variability to allow this to use these in multiple fields to compare how one field compares to another. So to do that, we are going to eliminate the areas. In this case, we're going to eliminate areas that are within 100 feet of the boundary. And then we are also going to try to target similar soil textures where from our soil survey layer, we know where the different soil types are. We want to identify the soil textures that all have a loam soil type to best represent this kind of a trial. If we don't like the default settings that we have set, we can edit those settings and change from 100 feet maybe down to 60 or 70 feet. That'll allow more areas near the edge of the boundary. But this eliminates, I would recommend having some kind of a boundary edge just to eliminate any areas that might have extra sunlight or errors from entering or exiting the pass with your application equipment when speed changes are usually still changing. After we've set all of our parameters for where we'd like to set the trial, we're going to go into the editor itself, and now you're going to see the trial itself and where it's in the field. If you look at the boundary of that field, you can see that there is a kind of a cross-hatched area along the edge, and that is our area that we are not allowed to put that trial. So that's our boundary buffer. If there is a soil type that we were trying to avoid or a soil texture that we were trying to avoid, that polygon that you see in the background there, one of those might also be crosshatched as well. The outline of the field trials themselves would also be outlined in yellow if we were touching a part of those restricted areas. And so since it's in black, we can see that we're in a good zone and that we're not in any areas we're trying to avoid. You can shift and rotate the trial as you need to across the editor and within the field. If you are trying to put the treatment or the trial in an area of the field that you know you're going to hit with your coverage of the field, you can also align these trials to a guidance line. And so you can see when we do that, we can pick from any guidance lines that were used throughout the management tree. So in this case, we've got an AB line for 2019, and we're going to snap to that AB line. If you had a curved guidance line, it would also show a curved guidance line, and the trials would match the arc of that curve, and they would size themselves so that each treatment was equally represented in the trial. Down at the bottom, you'll notice that there's kind of a grid of different soil types in this case. This is going to show you, we use soil type by default, but you can use other layers. This is going to show you where each of the trials are, each of the treatments, and how they are dispersed within other layers. So in this case, we have a soil type map. You can see that all of my treatments are within the Downs soil type. I could change that layer, and let's say I went to something like a management zone where I had different zones of productivity, and I could see where each of those treatments fell within those management zone layers. And the goal here is primarily just to try to eliminate bias. If you have different zones that the trial is spread across, to try to have each treatment given in the same kind of management zone to eliminate that bias. So that's kind of the goal there. You can use any zones you like or any kind of layer you like, from soil testing to soil type, management zones, irrigation, anything like that. All right, so now that we've got our treatment created, and we've got it placed where we want to in the field, we're going to incorporate that into a prescription. And so you can take either a basic prescription or a prescription created through the analysis wizard in SMS Advanced, and there will be a new tool in both of those editors noted down here on the right hand side where it says insert field trial. Now in this field I've just got a flat rate for the entire field, and we're gonna import the field trial within this prescription. So we're going to select that insert field trial, and it's going to place that trial in the same geographic area as the as we left the field trial screen a few minutes ago. And so now we can see that this trial is going to be incorporated into the prescription, so that when I get to the field and start applying the fertilizer, it is going to automatically change the rates as I get to that. I don't have to go through another step to load that prescription or a different prescription in the process. All right, so now we're going to go on to analyzing the results, and I can see here we've got in the analysis wizard, we've got a new field trial option there in the left-hand column. I've created a couple samples here, but I'm going to go through the process where we set up the dry banded fertilizer field trial. So I'm going to give it a distinctive name, just like we do in most other analysis functions. Okay, and then in this list, we're going to identify what trial we want to do. And so, in other words, we've set all of our field trials up. In this case, we've got a banded fertilizer and a liquid side dress. So I'm going to make a report, an analysis off of the banded fertilizer. So when I select the banded fertilizer, my year list is going to be filtered to only show those years that have a banded fertilizer treatment. And then it's going to also filter a list for the field name, so that I don't have to remember which field I created the trials in. It'll kind of show me a list, and I can build it from there. When I go to the next level, I'm going to set the harvest layer as my result. By default, it's going to pick the harvest layer. If you have other layers, such as in-season imagery, you can use another layer as well if you want to collect that information and compare during the season how a certain treatment might be working. Guys like oftentimes using nitrogen treatments, they'll use an in-season image to compare how the results are going during the growing season before harvest has started. Those are the two required items that you have to select. The other two items for the as-applied data set and the grouping item are optional. The as-applied data set provides you with the ability to track the application of what was done in the field. So in this case, I read in my as-applied data set from putting in the fertilizer. I read that back into the program, so I have a tracking of what my actual applied fertilizer was. If I've gone and added financial tracking information to those products that I applied, that'll actually kind of build into the analysis report for you to show what the economic advantage was for the different treatments. On the grouping item, you can use any layers for that as well. Commonly, people might use different hybrids to see how different hybrids perform underneath a given situation. So for example, if I were doing a fertilizer treatment like I am here, and I had two different hybrids that were planted through that area, maybe I was in a split planter situation, I could show I could split the results by the hybrid that was planted as well. This would work if I have different sections of a field that had maybe I had a field trial for fertilizer application in the high ground and one separate block in the low ground, and I had a different hybrid on the top and the bottom. They would work there as well. Okay. The next thing we're going to see is kind of a snapshot of all the report settings that we're going to be using in the treatment. And so the item in the top area, the result data set, that's the only area that's required to have something set. The lower items you can see by the checkboxes, like next to financial details and stats. Those areas are optional if you'd like to include them. For the result data set, we're going to go through these one at a time, just kind of give you an overview of each of those settings and what they might do. For the result data set, we're going to see a list of all the attributes that are available from within the harvest layer. And you can see that we've added yield dry to that list, and we've also added moisture. You want to have whatever the item that's most critical, in this case yield, as listed as a top item. Otherwise, all the other analysis is driven off the first attribute that we've selected. So you want to have that one listed first. Below that, you'll notice that there's a start and end of pass buffer checkbox. That would be the area where you would select if you wanted it to pay attention to those buffers at the start and end of each pass. On the lower left, you'll see that we have a checkbox for including the as-applied averages. Since I've added my as-applied layer for my dry fertilizer, I can turn that on, and what that'll do is add an extra column in my report to show how my intended treatment rates compared to the as-applied data. So I can see if there was some kind of mechanical issue or some kind of problem where I didn't have the right fertilizer rate applied in each zone. I can be aware of that. I can be made aware of that so that I don't base a decision off poor data. Below that, you'll see that I have an option to show custom field ID. SMS Advanced has had the ability to have a custom ID for each grower, farm, and field name. And what that allows you to do is if you are doing field trials for a number of different growers, and you want to share all of the results from every customer with each of the customers that was in the trial, you can make that so that it's anonymous, where it'll show that custom field ID rather than say a field name or a farm name that everybody might know of. And so the ability to show a custom field ID eliminates the ability for the people to know who did what. But if you have them give them a list of their field names and what their code name is, then they can track how they rank against the other ones that were doing the same trial. On the right-hand side, on the bottom, you also see that there's a minimum number of replications for the report. A lot of times in ag research, they say a minimum of 3 replications is a standard practice so that you can run enough statistics on the results to know if something is valid or not. We've got this set to 1, but you can set this to a minimum value where if you're polling a lot of different fields, it will only use those to have a certain number of replications. So you can kind of filter out those that only have 1 or 2 for your purposes. On the right, we have the option to select the item for the grouping selection. I've got it set to field name. If it was set to hybrid name or product name, that would be using the hybrid that was planted for that field in that case. I've got it set to field name in this example, but if it was using the defaults, it would be set to product name. The next item on the list is the financial details. And as I kind of alluded to earlier, if I have used the financial tracking tools within SMS Advanced, and I've set my product purchases values, my commodity sales, and my operational expenses, SMS will take all of that information and total it per treatment to give you the resolution that says, this treatment had this cost and this treatment had this cost based on what you've entered for your financials, and then it'll take the income from your harvest data and apply that to the treatments. If you don't have if you haven't gone through and identified the financial tracking entries, you can use the manual settings, and you can put in a standard price per bushel. And then on the expense, you can list off the cost per acre for each treatment that you had. Not all treatments will have an expense, maybe a tillage or planter settings. There may not actually be setting, cost to each of those treatments, but it's there in case you need it. The next item on the list is our statistics. We have kind of 4 different grouping items that allow you to see the trial results. Starting with the individual, this is going to be the highest level of detail. This is going to be kind of your field level or your block level, where we will show all of the replication results. We will summarize those results, and then we will show you the charts and as well as a map of where the trial took place for that field. Going down from there, we have the field level. So if you had, let's say, several trials within the same field, or maybe across 4 or 5 different fields, it'll show us a summary for each of those fields, and then it will show us a combined summary across every field that was used. The grouping level is kind of the same idea. However, in this case, let's say you had the same trial across several different fields, but they also had different hybrids, and you don't care about the field name, but you care about the hybrid that was used. You can compare at the grouping level with what I had set there in the first dialog with hybrid or field name or anything else. And the last item in that list is the field and grouping level, and this is where the data is going to be very specific to what was in different fields or different farms and by different grouping levels. So this can get really down to the nitty-gritty of each trial and how they fell in the field. So that's how our data can be merged and pulled apart. The middle section there is going to allow us to select which statistics we want to see on the report. By default, we are going to include the average, the standard deviation, the LSD, or the least significant difference, and the number of replications. The LSD is basically giving us a confidence level. We have several selections. We have 0.75, 0.90, which is the default, and then 0.95. So depending on which level of research you need to provide, for example, some university level researchers use 0.95. They want to have a very strong confidence level, and some on-farm trials go to 0.9 or 0.75. Either any of those selections work for you, we can run as you need it. The very last item, we can include a comment area. So if you want to provide details on the trial or information for the reader, we've defaulted it to showing just a real quick definition for each of those statistics to try to help convey what those mean for any user reading it. Okay. On the last item, we have the ability to set what kind of chart and maps are available on that field. So in our case, we've got 5 different rates that were used for the field trial. So we are actually going to be able to use a response curve if we wanted to. I could also use a scatter plot or a bar chart. For the response curve, we're going to get several different options of how to express that information. So we can show a curved formula as well as an R-squared. We can show the optimum value for the areas that had the highest agronomic response. We can show the maximum yield. And then on the economic side, we can show the rate of optimum, economic optimum. Then we can also graph those lines. We can graph the line for the optimum rates or their optimum values. And we can also show a scatter plot to kind of reinforce where those data points came from. And lastly, we can show the yield and the field trial, the as-applied data. Those two would be available on the individual report, but they would not show on the field, the grouping, or the field and grouping merge levels. Okay, so this is our report. And so this is an individual report that shows the individual results there on the left-hand side where the arrow is pointing to, and then also different there on the bottom right is the map that is generated with the individual report. So we're going to kind of go through this section by section to kind of highlight the different items here. You can see on the left-hand side there's different replications, 1 through 4, and then you can see the target rate. This is the rate that was used in the trial itself. And then the third column over is the average applied rate. And this is kind of what I was talking about, where we include the as-applied data to show that our treatments fell in line with what we intended to do. Okay. The next column over is the average yield from the harvest operation, the moisture level that we also wanted to include, and then the area. The area is important to kind of understand, to make sure everything was recorded and that every treatment was given equal representation for the trial. So a quick glance at those to make sure all the data is what you would needed or what you were going for. And then below that is a summary of that trial. So we combine all of the 0 rate, all the 91 pound, all the 138 pound, all those yield data values into one chart so we can kind of summarize everything. And you kind of follow that line where we have 91 with a star next to it. You can kind of see where when we get over to the profit and loss column, it's kind of our baseline. It's a 0 profit or loss. And so our profit or our loss is measured off of that for each of those treatments. You'll also notice that the last two items, the last two rows, 182 and 260 pounds, those two treatments are in bold text. And that bold text has to do with the difference or the increase in bushels per acre from the control rate, the 91 pounds. And so the significant difference, if you look at that value of 9.7 and 9.2, and then look down at the list of statistics where we have LSD at 0.9 and it says 7.7. So the LSD for the two high rate of treatments was greater than the LSD for the trial. And what that basically is telling you is that the treatments, those two treatments, are statistically significant, and you can attribute that the trial difference in yield was due to the treatments, and it wasn't due to some random chance. You can see that the 138 pounds had a result of 5 for the difference. And it's not in bold text because it could have been random chance that was a difference in yield. Okay, and so as we move on, we can see the comment area below here where it has all the comments we put in. And again, right now we just defaulted it to showing a definition of each of those different statistics. Okay, and on the right-hand side, we show the agronomic maximum on the left. So that's showing us where the highest yield was achieved and the pounds of fertilizer per acre that were applied. So in that case, the highest amount of fertilizer, the highest yield was achieved with 251 pounds of fertilizer. On the right-hand side, you'll see an economic chart, and you can see that with an optimum economic value, the optimum rate of fertilizer was 176 pounds of fertilizer. And below that, we can see our trial results. This is just really giving you kind of a peace of mind that the treatments were applied as you desired them. You can see kind of the dark blue rectangles on each start and end of the pass. Those are showing the buffer zones that were excluded in the harvest data to make sure that you're not merging data from the previous treatment when they're in a line like that. Those are also useful when you have a layout that's side by side, because you might have some other surrounding area, in that field that's going to potentially sway your results if you don't buffer that. So on the right hand side, the treatments were actually applied without that buffer. As soon as the prescription changed, the rates were changing, but it's still telling you those were excluded, because there could be some lag time in the controller to get the right trait set. Now we're going to show the same trial that was done across multiple fields and show you the difference in the report. So this is where I merged, instead of on the individual level, I merged on the field level. And you can see at the top of each of those first two charts, I've got home Dales, and I got replications of 3, and then I've got the sample farm West 60 that had 4 replications on it. And that second one is the one we were just looking at as an individual. And so you can see on the Dales South, the results there. In that case, the 91 pounds an acre of application was actually the most profitable. Everything else lost revenue. And so when you combine the results of those 2 fields and merge them together, we'll see the combined summary that shows that result. And you can actually see that kind of changed our significance level to a little bit higher, and so none of those are actually significant. Basically, what that tells me is one field responded, one field didn't. And so as we move on, we can see that on our response curve charts, that we see a row for each field name that was used, and we also can see the economic optimum for each of those as well. So on Dales South, the highest yield was achieved at 146 pounds an acre of fertilizer, and the economic optimum was 113 pounds an acre. Okay. And so when we average all those out, we get 3 lines. We get each field individually, and then we get like an all that shows every field that was included in the trial. Okay. So this report can actually be included with booklet printing. So if you have the booklet printing module and you print out data for your growers, you can set this to go out with their yearly summary of all their other maps, and so it's all kind of in one place. If you use Agfinity, you can export the trial information out to Agfinity, and you can view data during the growing season, such as on Agfinity Mobile or on the Agfinity app. And this will allow you to kind of see the information in real time as you're going through the field as well. For those that are in the research area, if you want to take the results of our treatments, of our data, and you want to use them in another program or publish it in a different way, you can actually export this information as an HTML, and you can open up an Excel and copy the data out as you need to. So quite a few different options to be able to get the information out and use for the purposes that you need. So with that, I thank you guys for joining us today, and please reach out if you have any questions. Call our support line, and we'll be happy to answer any questions you have. Thank you.